Yeah, hello Hacktivity. How are you today? I'm starting to feel fine. My first demo for today is actually inspired by an incident from last year when I wasn't allowed to come into this very room with a beer in my hand, so I figured how to solve this problem. So you have to give a presentation to drink beer in this room. Cheers, everyone. So my other project for today is called Heureka, which is a toolset that I developed. And it's basically about testing all those security products that you run on your network endpoints. But first, let me introduce myself for those who don't know me. I'm one of the leaders of Silent Signal, and I work mostly as a penetration tester in this industry. I also run a blog, as it was already mentioned, which is, I can safely say, one of the top IT security sources here in Hungary. Fortunately, it's in Hungarian, not in English, so some of you won't be able to read it. Sorry about that. This year for me was all about antivirus testing. Actually, I already gave a presentation about cloud-based antivirus on the Ethical Hacking Conference back in March or May, I can't remember. Since then, I've tested lots of antivirus products, endpoint security products. I tested them and I sometimes managed to break them also, but this talk will not about those break-ins, unfortunately, but about the capabilities of these tools. I have to admit that although the codes that I will present to you will be written by me and are coded in C++, I'm not an actual C++ coder, and I'm definitely not a Windows coder, so sorry in advance about all these memory leaks and possible, I don't know, buffer overruns that I still have in my code base, and please send me patches to let me learn. So, what do we know about this whole computer security industry? What do we know about this whole antivirus industry? Here's a quote from Symantec. It's a couple of years old now, and it says that the antivirus problem is basically unsolvable. So it is a well-known fact that you can't really decide if a piece of code is malicious or not in a finite amount of time. So antivirus vendors are brave enough to deal with unsolvable problems and provide solutions which can be used in real practice. And this is fine like this. If you talk about these topics with a reverse engineer at some malware research company or an antivirus company, he will tell you this same exact thing. They are well aware of that fact, even better than I do, possibly. The problem is, and this is where the security theater starts, and this is where the snake oil selling starts, is that every single security vendor has some badges from some independent research or testing company that says, okay, in real-world testing cases, this product will stop 100% or close to 100% of all the malware attacks that are used in the wild. And also, there are some tests about heuristic capabilities, which also say that at least two-thirds of the cases are caught, or maybe even higher, again, close to 100%. And the worst thing is, if you take a look at these papers, take a look at these statistics, you will be provided with some bullshitting, and you will get no information about the testing methodology and what exact malware was fed into those products. A very good example of this is that although these tests and these statistics show that 100% of the malware can be caught by these products, RSA, for example, could be hacked by a script-kidding Trojan, namely Poison Ivy. that was available for years before the same attack that was well known. Even your grandmother can use it, actually. And still, it was able to penetrate all the security systems of not just RSA, but huge security companies and government institutions. So what can you do about this situation? There are some pretty decent services like VirusTotal where you can test different antivirus products for yourself. But unfortunately, VirusTotal and almost all these services provide just a limited subset of the functionality of the products to be tested. So if you want to have a bigger picture and see if, for example, the embedded firewall can work against a piece of, I don't know, network tunneling payload, then VirusTotal would be useless to you because it just basically runs these signature engines on the tested malware. So what I came up with was to create a tool set for everyone to use, which can be used to measure all the capabilities of the security products that we want to or don't want to buy. So Heureka is an open tool set to assess the behavior capabilities of antivirus and also host intrusion prevention software. I designed it in a way that you can put little Lego pieces together. For example, if you want to be sure that your product will catch those, again, for example, some tunneling payloads, then you can construct with Heureka a set of test cases in which the different types of tunneling techniques can be examined and tested. Again, if you want to test if your security product can stop the recent man-in-the-browser malware wave, then you can construct a set of test cases where you can test this exact behavior. How do they react, for example, for DLL injection or, for example, to malicious browser extension installation. So you can basically create single standalone executables, which can be then fed into a testing system and see how the security products work on them. So I will try to show you some codes. It's a hacker conference, so what? I tried to keep it simple and stupid, and it worked. I can tell you that. This is one task that Heureka can do. This is plain simple. We allocate a readable, executable, and writable memory, move some shellcode over there, some obfuscated shellcode, then deobfuscate the shellcode. It's a simple XOR operation in this case, and then we run the shellcode. Think about the case when you have some JPEG exploits, and there is some stage 2 payload embedded in the JPEG file itself. So the stage 1 payload has to extract it from the file that was the trigger of the exploit. And there are lots of other small pieces of functionality put together, and they are glued together by this configuration file, in which I can tell that, okay, I want this binary to have some shellcode in it or not. Or I want this binary to have some XORed shellcode binary in it or not, etc., etc. I will talk about the functionality later. So what's the purpose of Heureka? My purpose is, first of all, to give some toys to antivirus hackers and to facilitate the testing of the behavioral capabilities of these tools. This way, I think we can do some nice research that then can be presented to customers, who then will decide which product they will buy. So effectively, at least I hope so, effectively it tries to influence the AV vendors' behavior also. As you could see, there is lots of C++ code involved in this project, but I have to tell you that if you are just a CISO, you can also use Heureka, since there are precompiled binaries which do some basic exercises against your product, so you can try it for yourself without creating a build environment and so. So here are some features, and I won't go through all of them. I try to implement those things that I found common in the recent malware attacks. So they communicate over the network, they access to some files, they search for some files, they access the registry, extract some keys, they do DLL injection in several ways, they hook the global Windows API. Actually, the Windows API is pretty nice. All this functionality can be implemented in like 500 lines or so. So a decent C++ programmer could do this or could write a custom Trojan, I think, in a week. I think that's a good thing to keep in mind. Okay, so what about the test results? This is what this whole presentation is about. I had a couple of contestants which I tested. Actually, this is not the full list, but these are the most valuable ones. I put them in 3 tiers, like the free tier, like in free beer. So you can download, for example, AVG or Avast for free from the internet. You get a bunch of crapware with them, advertisement and so, just like if you had a malware. And there is then the newcomer tier when these are smaller companies which try to present some innovation, some research, and I was very curious about how these new features work. And of course there is the hotshot tier, in which you can find those vendors which are over there for by every major companies. So here are some tasks that were initially implemented in Heureka. First of them was to set an automatic startup in registry. You know, if you put a program path into the appropriate location in the registry, then that program will start up every time the user logs in. Damn simple, all the old school malware does that. The other task was to write some domain IP association to the host file. This is very typical to banking Trojans. For example, if they want to redirect all the requests to bank.com to a different IP, they just have to modify the host file on Windows. And this way they can facilitate some phishing attacks. And now I want to play a game. What do you think? How much percentage of the tested vendors did recognize these features or these actions as malicious? Who thinks that it was about 75%? Please put your hands up. Nobody. Oh, there are a few. Okay, who thinks that it was about 50 between 75%? Yeah, some more. Who think it was between 25% and 50%? More people, okay. And who think it was below 25%? Again, many people. Okay, you have some good intuition. These are the numbers from my tests. So it was about 40% for each task or each feature. This was the detection rate. So 60% of the tested products didn't realize that these actions can be malicious, or didn't alerted me, or didn't put a note in their logs. Altogether, there were only 3 of 10 products which alerted me in both cases. So it's like 30%. So those were right who put their hands up when I asked if it's between 25 and 50. These are the my results, at least from one point of time. It's intentional that it's so small, so you cannot read it, because it's not about telling which vendor is the best or which vendor is the worst. It's not about that. It's about tendency. It's about taking a whole picture about how the industry is looking like. And as you can see, we have very many red spots, which means that those test cases with that particular vendor, just went through like hot knife through the butter. And I have to tell you that the other reason why this is printed in so small is that this results table just represents 1 point in the time. If you try to test, and you will have the opportunity, I promise, to test antivirus products and see that, okay, this test case works fine, everything is recognized by the antivirus, and then you redo the tests a couple of days or a couple of weeks later, you will probably see quite different results. So this is my pure excuse for the following demo effects. Antivirus is non-deterministic. So there was a case, I will talk about that later, okay? Let's just see the first demo. It's demo time. So our first demo will be, okay, before I start, in the demos I wanted to focus on one single thing, namely network communication, data exfiltration, because I think this is one of the most critical points an attacker has to take care of if he implements a kind of malware. If you cannot talk to your bots, if you cannot send out new payloads, if you cannot exfiltrate data, then you're pretty much fucked, because there is some piece of software running on that computer. Maybe it flips the screen and opens the CD tray, but you can get nothing out of that, except of fun, of course. So here we are. This is Symantec's endpoint protection. Who is here from Symantec? No one? Maybe that's good. So here we have 3 modules. Here's the standard virus and spyware protection. We can see the settings. Everything is enabled. Bloodhound technology is in place. We have proactive threat protection, and this is what we are interested about in this case. We have sonar enabled, and we also have some firewalls enabled also. So everything is set up. Most of the test cases are set up in a way that are at a higher security level than usual. So I try to make these protections very robust and secure. Let's start some packet capture. And so the basic network communication task is like running a connect back shell. So let's run one. This is straight exported from MSF payload. So it's a Metasploit output, no encoding, no shikataganai, no other encryption bullshit. It's raw shellcode. And it connects back to our web server, which will be interesting. So here we go. I just launched this manifestation of Heureka, and in the background, you can probably see that some network communication was in fact done, and here we are. This is our connect back shell, and this is how it looks like if your connect back shell tries to communicate with an Apache web server. Here are some funny things like the data that is interpreted like the date command and so on. So basically, Symantec didn't give a shit about that vanilla connect back shell is running on this computer. I think that's a shame. So let's see another product, but first I have to restore another snapshot for the next demo. Next one will be F-Secure. Unfortunately, Mikko can't see this because he had some other jobs to do. So here we are. This will be from the free tier. This is the free version of Avast. And here we also have some shellcode executing executables. Here we are. In this case, I didn't put in an aggressive payload. It's just a message box. But this will not matter, I think. I tried to launch this executable, and here I get a pop-up that says that I don't know this program. What does it do in this computer? So Avast has some kind of reputation database that takes the track of every single executable running on your computer. And you can say independently that, OK, I want this, I want that, I don't want this, I don't want that. That's nice. I think that this is how every security product should work. It needs some training, then it works with quite a few false positives. The sad thing is that if you remember, or if I launch this executable again, then you will see that the shellcode did actually run. So although this window says that, OK, I stopped the execution because it might be malicious, if you're fast enough, faster than Avast, then you can run your shellcode, actually. So let's go back to the hotshots, shall we? This is F-Secure. And in this case, I constructed a different payload with Heureka. In this case, I would like to show you a download and execute case. This is also very trivial for a malware to do. Maybe I want to load some new modules or load some other malware to place more advertisement in the Internet Explorer browser of the user. So what we do is use the WinHTTP API, send an HTTP request to a remote server, fetch an executable, save it to the disk, and then run it. What will be the consequence? OK, here we are. Yeah, this is the download exec.exe. And as you will see, F-Secure is actually one of the fastest of the products I actually tested, but it's also pretty damn slow. It takes a few seconds before anything can trigger because there are very heavy analyses in the background. OK, waiting, waiting, waiting. This is the point where the user starts to uninstall the security product. And here we can see another good thing. This product just notified me that here is an application that tries to connect to the internet. Do you want to allow that? That's a very fair question, and this is a question that I think every security product should ask. Because strict security is good security, that I will talk about later. So I can say that, OK, deny this connection request. But not all the hotshots and not all the vendors do the same. Let's load, for example, Kaspersky. It will take a while. Who's from Kaspersky? No one? Ah, that's sad. I'd like to talk to those guys because I didn't have any chance to talk to them yet. Yeah, it doesn't really matter if you see something on the screen. The VMware is just starting up this virtual machine. We have to wait some more seconds. Let me ask you, who is here at Hacktivity for the 10th time? Only me? Oh, there is one other guy. Hi, we should have a beer. OK, can we do something now? Baby, please. OK, here we are. So here's Kaspersky. It also has firewall enabled. This firewall is, of course, application aware. We have no whitelist rules enabled. And I will just launch this h.exe, which is another instance of the same download and execute payload that I showed you before in case of F-Secure. OK, as we can see, something has just happened, and we have just downloaded a keylogger, which is another instance of Heureka, and it's running happily. We can start a notepad and say, hello, Hacktivity. It's almost lead time, according to my virtual machine, actually. So I close this, stop the keylogging. Yeah, there is some message box shellcode also in this binary. So there are 2 models actually in this binary. And we can now read out the results. It's in a hidden file in the temporary directory by default. Yeah, and this is it. I log all the key down and key up events, so everything is doubled. But I think you can see that it just worked. And Kaspersky didn't say anything about download and execute payload, and didn't say anything about keylogging. Actually, first, sorry, I have to restore another snapshot. But I will tell you a story about keylogging because I've found that the most interesting part of this whole testing process that I've done. Yeah, here we also can restore this one. So, where is my presentation? Oh, it did just disappear. I'm sorry. So basically, there were only 2 products out of 10 which were capable of realizing that, hey, there's a keylogger running on this system, which is not good. Actually, I can't imagine a situation when hooking the low-level keyboard API of Windows would be a legitimate purpose. So these 2 products were Symantec and F-Secure. But this was one of the cases when I tested this out a couple of times, and okay, I was quite sure that these 2 products are capable of detecting keylogging. Then I put aside this project for a couple of weeks, and I got back into it, and I rerun all my tests to make sure that everything works fine. Well, everything was not fine because after this short period, neither F-Secure and neither Symantec was able to catch this very same payload from the very same virtual machine's very same snapshot. So I'm really interested about how that could happen, but it just did, and I tested it with fresh installations, with the newer versions, with the downgraded versions, but right now, none of the tested products can actually catch a fucking keylogger. This is the only screenshot I have actually about one of the good runs when F-Secure did actually catch that. It's in Hungarian, so I tried to translate it quickly. So DeepGuard has noticed that a program is trying to fuck with another program's memory. And that's okay. That's what these behavioral detections tools should do. But it turns out they don't do that too much. So we have some other demos. Yeah, fly, little snakes, fly. Let's talk about ESET. If I can, yeah. My VM is fucked. No, it doesn't matter. So in ESET, you can set up this thing called interactive filtering mode. I just enable it. And soon you will see thousands of pop-ups saying that, okay, Windows is trying to communicate with the internet. Okay, I allow that. And Internet Explorer is trying to communicate with the internet. Okay, allow that. So I can browse these very fine wallpapers, ESET. In this case, if I try to run the same download and execute payload, well, I get an alert, and I can say, okay, remember this action, and deny that motherfucker. Okay, that's fine. But what if I run another Heureka payload, which executes an Internet Explorer process, injects a DLL in that, and that DLL tries to connect back to the internet? So the DLL is loaded, and the download and execute exported function of the DLL is running. Here we can see the Explorer process starting up. And we have to wait, I think, a couple of more seconds before our payload triggers. Oh, yeah, here's our keylogger is running again. So here, this way we can circumvent the application of our firewall also. I have to tell you though that this DLL injection code is so realistic that most of the vendors recognize it by signature matching, actually. So I managed to produce a signature from source code. That's a nice thing, I think so. So, but there are some interesting things also in this case. For example, here is Microsoft Security Essentials. This product was not really a part of the test, but it's a very basic tool. So you may know it can do signature matching very fine. Actually, this is one of the tools on VirusTotal that I tend to not circumvent. So, oh shit. This is Windows, not Linux. So I just try to deploy, which machine is it? This is the first machine, okay. Deploy a payload that's it's capable of enumerating all the processes and finding an Internet Explorer process and trying to perform DLL injection on that process. Okay, it's up there, it should be up there. Oops, something just happened. But it's not the alert yet, I think. Or maybe it is, yes it is. So, here's an alert saying that this file can be malicious and this alert is right. Okay, and don't send this report to Microsoft, please. What if I do the same with an executable that doesn't perform process enumeration, just launches a new Internet Explorer instance and injects the DLL into that, just like in the previous demo. Okay, here we are. And this one just runs. So it turns out that Microsoft Security Essentials is irritated by the fact that I try to enumerate processes, but not by the fact that I want to inject DLLs into Internet Explorer, which is not a very nice thing to do anyway. So these are just a few examples about what tests you can perform using Heureka. I, of course, talked to the vendors about this. I sent them nice reports telling them that, okay, you're failing to cache the keylogging module, and you fail to realize that there is a common shellcode in my binary, and you fail to realize that I tried to perform DLL injection. And the reaction was like this. So I sent him all my materials, and I got back nothing, thank you, or we will take a look at that, or something. But anyway, thanks for the cooperation to those guys who actually managed this process at ESET, Symantec, GDT, and F-Secure. They were actually pretty nice, but the bureaucracy of the security vendors, I think, just followed my reports. So what's the conclusion? According to my recent experience, so this many months of testing, I found that the current capabilities of security products could be good, could be wisely implemented. One problem is that these security products are working like lazy policeman at the Keleti railway station. So maybe he will do some identity check, and maybe he will catch some criminals, But most of the time, they will miss them, and most of the time, even especially if they are drinking their coffee, they are not very capable of do anything useful. However, if these police people could learn from each other, if the vendors could implement all those things that are already implemented in different products, if those things were implemented in one single product, that would be a really good product, I think. This would catch almost all the criminals. Another question is that this would be a police state. So if you want to run such a product, then you have to have a good reputation database about your programs and about your processes. And you have to train your police staff, your security products, before using them. You have to tell them that, okay, this is my banking application, don't fuck with that. This is not something I am aware of, so please check that out. I think the time of ruining a security product because of the false positive results are over. I think that false positives should be handled in a way that we customize actually our security software. So not just install it and it will work, because it won't. Because every system, every software ecosystem is different. You have to tailor your security products for yourself, for your own specific environment. And here's the time for release. I hope that everything will work. I just, oh shit. I just say git push origin master. Okay, this is me. I hope that I got the password right. Okay, now you can grab the copy of Heureka at this URL. And please, there is lots of things to do. So the current functionality just provides the most basic things that a malware is usually capable of. We should do privilege escalation, we can do virtualization detection, we can do antivirus techniques to have more test cases, and somebody should implement these. And we should do lots of testing with these new and existing test cases. And after we did the testing, we should encourage our vendors to do their jobs better. Maybe one can also build a fully automated testing suite out of this whole concept, just like VirusTotal, that would act like I want to test if my product just is capable of detecting, for example, keylogging, then this service would be capable of providing me some answers. Maybe we should do some architectural redesign. I'm not sure about that. As I told you before, the whole hot glue between the different modules are basically preprocessor directives, which prevent non-used code to get into the compiler. But maybe this could be better achieved by separating the functionality to different .h files or creating static libraries. I don't know, but I will really appreciate your comments about these. So if you have any questions, I will be here the whole day. And if you have some favorite vendor or the vendor you are using, you can bring me that software. I have many test cases by my computer, so I can check out what that particular product is capable of and what it cannot do. Greetings to all my fellow hackers here in the audience and elsewhere. And see you tonight at the 90s party. I would like to invite everyone to have a great time tonight. We have 90s. We will have a 90s costume contest and Gringo Warrior game, and some Aurora shots, not the exploits. So it starts right after the last presentation of today in front of this auditorium. Here are some links if you're interested, and thank you for your attention. Any questions? No vendor wants to kill me? Okay, thank you for your attention again. Have a great time.